Hello, everyone. Uh, Today I'm going to be solving two LeetCode easy problems that I did, like, let's say, what was it, 3 weeks ago, I believe? Yeah, like 3 weeks ago. Um, just to make sure that I really understood them and I can recreate the solution. We'll see if I should, well, hopefully, we'll see. Doing two because I don't feel like doing a new medium. Energy is on low today, even though I should, but that's okay. So yeah, let's start. I'm gonna share my screen. I need to really make sure I do this correctly because I had like a 3-hour live stream where I didn't share my screen, which was kind of insane. I'm gonna try something new. I'm gonna share a window, I wonder if that will look better on the stream, because when I shared my entire screen, I feel like it just didn't look as well. So we're just gonna share the browser, which is Brave. That's what I use. Ideally, I'd stream again today, maybe like at 6 or something, so I can solidify the work I was doing on my project. But yeah, for now, let's do this. Cool. Okay. So first problem we have is duplicate integer. It basically states that given an integer array nums, return true. So like this, right? Return true if any value appears more than once in the array, otherwise return false. Okay, so I guess the default solution, right, would be to go through the array twice, and what would it be? To check you have let me think about what I would want my solution to be. Even the easy ones, you're going to struggle with. By you, I mean me. Hopefully you don't. Okay, just the first thing that comes to my mind is just as you iterate through the list or through the array, put every element in a dictionary or actually, no, it doesn't have to be a dictionary, just put it in a set, and put it in a set only if you've seen that number more than once. And then at the end, if your set, because it's any value, right? At the end, if your set is empty, then that means we haven't seen a number more than once. So that would be example 2. And then if it's not empty, if there's elements in it, that means we have seen an element more than once, which would be example 1. So let's just try to implement that right now. I'm trying to think, does it even have to be a set? Like, I could low-key just use an array too to do the same thing. But let's just do the set idea first. So I'm going to call this let's think of a good name for this set. So I believe this is how you make a set in Python. I'm going to have it be equal to, that's where we're going to store our duplicate nums. So if the number has a duplicate, it's going to go in this set. Okay, but we know for sure we have to iterate through the list. So to do that, you can just go for every num in nums. At least in Python, that's what you can do. Now, we can have two conditions. We can say if set we can say if num in set then I guess what we really should do is, I'm trying to do this in one iteration, but it's giving me trouble. Okay. So I think first thing we're going to do is add the number to the set. So I think we can go set dot insert num. I'm not sure. Is it add? What's the Python function for this? We can look it up. How to insert into a set. Yeah, you just use insert. Python. Add. Okay, cool. That's what we're going to do. We're going to do add. We're going to add the num, and then this is where it gets pretty stupid. Man. Sorry, there's like a whole thing going on outside of my window. It's distracting me a lot. Maybe I should close my window a bit so I'm not as distracted. Okay. So yeah, energy is not here today at all. I forgot to put a timer. It's fine. But basically, so I just got my permit, my driver's permit, like 3 days ago. And I have a viewer. I wonder if it's Michael, my friend. Oh, crap. Doxed. Even though Michael's a common name. Who knows? Okay. We're going to continue the problem then, and we're not going to tell my little story about how I got my driver's permit if somebody's actually watching. So, you know what? I think I'm just going to do the crude solution first, the slow one, and then I can think about how to optimize it later. So I'm just going to iterate through the whole list, add every number to a set, and then iterate through the list again. And then basically check if num. Oh, wait, that's stupid. And there goes my viewer. You hate to see it. You know, I'm telling myself that I'm doing this to be like, so I can be consistent in coding, but not gonna lie, when I see some sort of numbers like view count, you know, or someone's like joining the live, or God forbid I like a video, I get a like on my video, it's kind of impossible not to like want to grow. It's cool. But the focus is daily coding and getting used to talking on camera while doing this. Why is this problem giving me so much difficulty? This is insane. I definitely did not remember the most optimal solution. Okay. Could we set a Boolean flag? Oh, this is an interesting solution I just thought of, right? Sets can only contain, the whole idea of a set is that it only contains unique elements. So if that's the case, I can just check, I can add all the elements to the set. And then if the size of my set is any different than the size of my input array, then I know that a value had to appear at most once, or at most, one of the values had to appear at most twice. Oh, actually, that made me feel smart. Okay, wait, let me double check that. In Python, can sets contain repeat elements? Yeah, okay, cool. So I think that's what we're gonna do, right? We add it to the set, then if set, how do I get the size of the set? Oh, oops, hold on, let me get rid of this. This is my live stream tab. What is this tab? Oh, this is the actual YouTube app. Okay. Oh, and that's my code. Oh, but you guys can't see anything, just looking at the tab. Ooh, that's cool. Okay. So if how to check set size Python, I can just use the length method on the set, it seems. Okay. So if length of my set, which is called duplicate nums, I love how I didn't even use the name of my set here either. I'm gonna just call my set S. Sorry, I can't think of a good name for what I'm trying to do right now. So we'll just call it S. And if the length of our set is not equal, or yeah, is yeah, if the length of our set is not equal to the length of nums, so let's think about this. Little if else action here. I mean, I guess it doesn't matter. That makes more sense, right? If the lengths are equal, then we return, or I guess the true condition here is if any value does appear more than once. So maybe we should kind of reflect that ordering here. Return true. Right, capital for Python. And then I can just put a return false here. I'm not even sure if I need to put it in else. I could think about it for a second. Surely. Okay. So we made a set. We add all those elements to the set. I can write this down as a comment here. Key point is that sets can only contain unique elements. Okay. We add all the elements to the set. Again, if I can't add a 3 twice because that's just how sets work, right? So if the set is a smaller size than the input list, that means I don't have a list of unique elements. If I don't have a list of unique elements, that means at least one value appears more than once, which is enough for us to return true given the problem statement. As far as the runtime of this, this is just O of n here. I'm just iterating through the list once, and this should be a O of 1 check. Again, like we're not really sure how long it takes to calculate the length of each of this array and the set, but in theory, this should just be a O of n solution. Iterate through everything once. Yeah, there might be, well, let's just see if this works first. Okay, so this works for the first two cases, which is good. Now let's see if it passes every test case. Can I think of an edge case quickly where this wouldn't pass before I try to submit it? Okay, if my list is empty, because I'm not guaranteed anything about the size. So if my list is empty, both lengths are going to be none or 0. They should just be 0. Both lengths. If length works correctly, both lengths should be 0, and it'll return true, which is good. If I only have one element in the list, again, both elements would be 1. If my list is entirely duplicates, then yeah, they're going to be different sizes too. To me, I think this should work for every case. Let's try it. Cool. Okay. Now to think about so yeah, as you can see, I did do this on the 20th, which is 11 days, a week and about 2 weeks and almost 3 weeks ago. What was I doing? Oh, so I want to say, is there a way to do this in faster than O of n, like log n? What would a log n solution look like? I'm not sure. This feels like I could check out my code earlier. Okay, we're done with that. Dope. What we're going to do now is, and I think, again, let me write this down. Then worst case runtime. Yeah. Just doing a linear scan. As far as the space complexity, at worst, it's also O of n, because at worst, my set is always going to be the size of nums. Yeah. So that means I believe, I could be wrong. I also have an O of n space complexity. Worst case. Worst case. Cool. Okay. So yeah, I'm just gonna play the LeetCode solution now. The NeetCode solution, my bad. Unfortunately, I forgot my AirPods, so I'm going to have to play it through my headphones, but right now it's connected to a speaker. Damn, I was listening to X. I was going through it. So I'm going to turn my speaker off.
Battery high.
Did that turn off the speaker? It seems it did not. Yes, speaker's off. Going to turn on my headphones. Sennheiser Momentum 4s. Honestly, not worth it. That's my take. It's my audio review. Put those bad boys on. Now they're connected. Now let me pray that it's still using the right mic. It is. Perfect. And I believe I did select share audio as well. Let's hope I did. If not, not like anyone. Okay. I'm going to stop sharing and then share again just to make sure I'm doing that. I am also sharing tab audio. Perfect. Okay. Here we go. We're going to play the solution. So right now I'm thinking O of n is the fastest possible solution. We're probably going to get clapped right now with using a hash structure, but a set also does use a hash. A set is basically also a hash set. At least I don't know how it works exactly in Python, but traditionally, the reason why it doesn't allow unique elements is because we basically hash every element and with a hash function, and then we assign each element to a bucket, so to say, right? Yeah, I'm not sure actually. So we're going to review this with the LeetCode explanation video. Boop, boop. So hopefully this doesn't, let me lower the volume a bit on this, just in case. First, I want to see how I solved it 3 weeks ago. I'm completely honest to God, I really have no idea how I did it earlier. I mean, this code seems pretty clean, but let's see. I feel like I didn't make this realization, but we'll find out. So this was my, oh, wait, this is my solution. Oh, sorry. It looks bad because I have the font size set higher. Oh, this is interesting. So I did use a set as well, but I called it has pair. So I said if at any point the number in has pair uh, so it seems I added it to the hash set, right? And if at any point, oh, this makes sense. This actually seems faster, to be honest. So what this is basically doing is saying we're adding each element to the set like we are here, but if at any point we're adding a number that's already in the set, then we can just return true there. So why is this faster? Because there's going to be a lot of cases in which you won't have to iterate through the entire input list. There's going to be, yeah. So basically my code, worst case, average case, every case, it's doing an O of n search, linear scan. This has the opportunity to stop earlier. Only in the worst case is it O of n. Best case, it could take just like 2 computations or something. Wait, yeah. I guess if you have like a list of size 1,000, and then the first 2 elements are the same, right? So that's a size. I mean, that's a big difference in this code. In my example, right, of a list of size 1,000, I'm going through every single element in that list of size 1,000. assuming the first two elements are 1, 1, and then whatever. But here, as soon as I hit that 1, 1, I'm done. So two operate two operations versus 1,000 operations. It's kind of a big difference. Let's keep watching the video. Okay, so this is interesting. At least twice. I'm pretty sure that's not how the problem was worded. I hate that when I switch to question, it's going to reset my progress on here, but that's fine. If any value appears more than once. I wonder if at least twice makes things more clear. I'm not sure. 55. Boop. Hmm. I don't know why. It didn't even come to my mind the O of n squared solution where you check every number against every other number. Whoa, 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 whoa. Oh, I see. Right. So, yeah, I need to maybe reconceptualize my idea how space complexity works. But all right, I think I just got it right now. Basically, we didn't introduce any new data structure in this brute force solution, so I have a constant space complexity. I'm not using more physical memory in terms of like storage in order to solve the problem, but I am taking a lot of time, right? Uh, the bound for my time is fairly significant in this brute force solution. So given that, uh, in my first solution, oh whoa, glitch. Let's try to. That is not. Oh, funky behavior right here, NeetCode. Um, right. So this isn't like just O of n worst case space complexity. At least in this implementation, this is like always the case. Best, worst, average. I'm always using a set. And let's keep going. I might need to refresh my knowledge on the space complexity of a set. I think if it's O of n though. So it seems like for this sorting algorithm, you sort the entire array, which should take log n, right? And you're not adding any extra space complexity, uh, at least not a linear one, because all you're doing is checking. Yeah, all you're doing is checking the previous element. So you probably just make a variable, right, that stores the previous iteration's element. Yeah, but then how many of those would you make? Could that be like another O of n space complexity? Not sure. Let's keep watching. Oh, oh, that's right. I have to sort it, which is login, and then I have to do another pass to check if I have any of the same number next to each other. If you notice, whenever I play audio, I'll get the little crackle. Super annoying. No idea how to fix that. Been going on since I've tried to record anything with this computer or laptop, I should say. As you can tell, this isn't the best. This isn't the craziest device ever. Need I need to upgrade soon though to like an actual like desktop at some point, but it's gonna have to wait until I'm employed because I do not have the money for that right now. That is true, right? Yeah. I honestly I definitely do need a refresh on my okay, algorithms for sure. Like for some reason I suck at algorithms. I'm definitely capable of doing it. I've done them before, but they're not committed to memory. But in terms of data structures, uh I definitely need to refresh my memory and data structures because even though I'd be able to like I mean hopefully I'd be able to like solve a LeetCode easy, right? In terms of the exact like details and intricacies of uh what kind of data structures, how much space each one uses. Not sure if I'm completely I mean I tried to explain it and I couldn't earlier, so I definitely need to work on that. But okay, hopefully I remember this one. Yeah, and it does have O of one lookups and insertions, but it uses more memory. I just don't remember exactly how it uses more memory. Uh, hopefully he explains that. If not, I'm gonna refresh my memory. Or okay, yeah, I think I need to go away from predetermined concepts of what data structures or how much memory a specific data structure uses, because I kind of had it right in the beginning, right, where I was saying that my hash set can only be at worst as big as the list, which is O of n. So then the answer is the memory that that hash set uses is O of n. Right. If I use an array, it'd be the same thing. Okay, yeah, okay. In terms of space complexity, right? If I was using an array to store the duplicate pairs, then it'd also be at worst O of n. However, the reason why we're using a set is because, as you saw, um, the insertions and lookups are O of one in uh, every case for hash sets. But the insertions and lookups for an array are, I'm pretty sure, yeah, a lookup can at worst be O of n, and at worst be O of n for the insertion as well. Like depending on how it's doing it. Like if you're just using a regular list, not like a doubly linked list. Yeah, okay. So if I was using an array as my data structure to check if I had duplicates instead of a set, I would have the same space complexity, O of n, but my time complexity would increase, right? I'd have something like O of, hmm. Oh, damn, that would be really weird. So obviously you'd have to go through the whole array. So the time would be O of n minimum, and then if every insertion and uh, lookup also took O of n, oh, would that would might I might be tripping, but I think that might be like so for one object, I'd have to do something n times and another n times. It could be like O of n cubed. I'm not sure if that's correct, but damn, basically sets help. Okay, continue. And at this point, I think what he's going to write is exactly what I wrote for my first solution 3 weeks ago. Really interesting that I found the most optimal solution 3 weeks ago and I didn't find it today. But I guess that's why you repeat the problems to make sure you learn. Hopefully I don't forget. Okay. Yeah. So just to recap, I mean, I don't, yeah. I feel like it helps to know exactly what your solution is going to be before you start coding anything. Uh, which seems like an obvious observation, but I feel like I can't hold so many things in my head at once, and I need to just write something down to like get the ball rolling. Um, but yeah, but okay. Again, basically, we the order you want to think of this in is like you first add to the set that you made, and we can change this to we can call it duplicate check because that's its purpose, right? So you add into this duplicate check set every number. But if the number you're currently at is already inside the set, then we know we found a repeat and we can immediately return true. And if we go through the entire input list, and we never were able to find a duplicate, then we know there are no duplicates and we return false. And this should also just work as he showed above. Cool. Okay. Now let's do the other problem I did 3 weeks ago. Man, I'm honestly going to have to pick up the pace. I want to get to at least here, right? Maybe at least here. Definitely want to finish arrays and hashing, 2-pointer, sliding window, stack, binary search, linked list, trees, heap, priority cube. Yeah, I definitely. So how many problems is this? 16, 25, 32, 47, 47, 58, 65, 73, 79, 84, 93. Okay, hopefully I did that right, but damn. So I want to do around 93 problems and really know how to do around 93 problems before I'd say be like, I feel comfortable doing LeetCode in job interviews. And I mean, my goal is to get a job within the next 6 months. Whether that's possible will be heavily dependent on something like this. You know, I've made a lot of project in my progress, as you can see in the live streams. And I find it really easy to work on my project, which is like, makes me happy, right? Because that means that, I mean, I've already pretty much completed one project I can put on my resume. I might need one more. Probably will need one more. And that's fine if I do. But I want to be ready for those interviews, right? And to get a good grasp on 93 problems. So obviously, not like problem a day, that's around 3 months, which makes sense. But 3 problems a day, and it becomes 1 month. But honestly, okay, that is going to be hard, and it's going to take a lot of mental energy. But I'm unemployed, and I have nothing to do. So I'm going to shoot for that. I'm going to shoot for 3 problems a day. A realistic goal is going to be 2 problems a day. And that's going to be like 1.5 months. And bare minimum, 1 problem a day. But the length at which these problems take is going to be vastly different for me, like every time. I had one that took me like 2 hours, 2.5 hours a medium. And this one took me, and I'm also going to have to review the old ones. So we'll see. We'll plan out like a study plan or something at some point. But for now, let's do the second problem I did a while back, which is valid anagram. Okay. You're going to have to trust that I'm going to press the reset code button and not look at the code that's already there. Okay. Okay. We're good. We're good. I do want to see, when was the last time I submitted this? Yeah, so I did both of those the same day. And then I did, yeah, it's hard to grind LeetCode for me. Okay, cool. Also did this one around almost 3 weeks ago. Wait, am I doing that right? 3 weeks ago. One, 2, 3. Yeah, almost 3 weeks ago. Okay. So let's see if I remembered the best way to solve this. I should remember that the topic is called arrays and hashing. The overall category of problems where the overall category of problems that this part of the NeetCode 150 falls under. So probably going to use a hash set or a hash map. Remember, the difference between a hash set and a hash map is a hash set just contains elements, right? And it has that O of 1 insertion, lookup, and deletion that is so good about sets. Obviously, the trade-off is that sets don't preserve order. So, and they take up more memory in the worst case. But I mean, any data structure takes up memory. But yeah, the a set has, okay, I went over this in Python. Apparently sets do have order because of the way they do it in the back end. But for interviewing purposes, I think it's fair to say that a set theoretically has that constant time lookup, addition, deletion, and but has no order to it, where a data structure like an array, which we can just look at those two right now, an array does have an order to it, right? It can be ordered in some way, and that could be very useful to us if needed. Kind of rambling here. Okay, so this problem is anagram. Given two strings S and T, return true if two strings are anagrams of each other. Otherwise, return false. Okay. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Right. So one thing immediately is that these strings have to be the same size. And if they're not, then we would probably automatically return false because there's no way they can be anagrams if they're different sizes. Two, and they also have to have the same amount of letters and the same amount of occurrences of the same letter. So if I have two R's, then if my string S has two R's, then my string T has to have two R's. So that's something that could also be important. We know at bare minimum that we're going to have to okay. So one solution could be using a hash map, where I have a key being the letter that we're currently at and the value being the amount of times I've seen that letter. You basically would make a map for both strings. And because both strings should be the same size, you should be able to iterate through both strings at the same time. Let me think about this. Yeah, you should be able to iterate through both strings at the same time. And then, but I'm not sure if that's any different than doing two for loops. We'll see. And then at the end, you check if the dictionaries are Python dictionary, but it's a hash map. If the hash map you created is the same, is the same. Yeah, and in Python, I know you can directly compare dictionaries by just literally using the equal sign, and it basically checks if all the key value pairs are the same. Anything else I would need to worry about before I implement the solution? The space complexity. So this dictionary is always going to be the size of both input strings or the size of one of the input strings. No, okay, my bad. I'm making two dictionaries in the solution I'm thinking of, and uh, each dictionary is going to be the size of the input string. So it's going to be something like a O of 2n space complexity, but we can drop the constant, and like it realistically scales with O of n. As far as time, I'm gonna need to iterate again through both strings completely, do a linear search, and that would also be an O of 2n time complexity search. And if we drop the constant, uh, that would simplify to something like O of n. Yeah, I don't. I, I know dropping the constant is like, what's the word? Traditionally accepted, but it still feels kind of wrong to me sometimes. But anyways, yeah, I'm gonna implement that. Before I do, I think there's another possible solution, and that would be making some sort of character array. By that I mean you change each character in the input string into its corresponding. No, actually, you would make a list. You would basically make a. Okay, actually, the solution isn't as good because the char array, how that works basically is you have a char that is default set to a size of 26. You fill it in with 26 zeros, and every time you see a letter, um, you convert that letter into its ASCII representation. You subtract off. In this case, we only have lowercase English letters, but you subtract off the offset from what the lowercase letter a is, so that lowercase letter a represents 0, and then you index into that character array using the uh, offset ASCII value you calculated, and then you add 1 into it every single time you see that letter. And then at the end, you compare both character arrays. Fun fact, that's how you do anagram groups, the most efficient way. But, or according to NeetCode, the most efficient way. But this isn't the most efficient way for this problem because, or wow, that's actually a very interesting problem to think about. Right, if I have any two strings that are less than 26 characters, for example, like what if one of the constraints was your strings will always be less than 26 characters, then this dictionary solution makes more sense because in theory, at least, who knows, maybe running it, whatever Python does under the hood is completely different. But maybe the dictionary solution would be faster because would use up less space because my dictionary space would never exceed the static size of 26 that the character array uses. Oh, I'm thinking of big O complexity differently. So technically, I guess the space complexity of a character array solution, because it's a constant of 26, would technically be something like O of 1 because it doesn't scale with the input size. Every single time, the character array is going to be the same size for any string of any size, whereas the dictionaries would scale with input size. So what does that tell me? Let me actually write stuff down, what I'm saying. What I'm saying is we have in my humble opinion, too efficient, time efficient solution paths. The first one would be to build 2 dictionaries where the key would be the character, current character, and the value would be the number of current character occurrences. And then at the end, basically, then compare both dictionaries for quality. Our second option, I believe, is it's more complicated, but to make a character array for both strings. Yeah. And I explained how that works, but then check character arrays for equality. These both have time complexities of O of n because they would require a linear scan through both strings. So 2n, but simplifies to O of n. But they have different space complexities, where I believe the second one has a constant space complexity of, 26 times 2. So what is that, 52? And the first one has a space complexity that can scale with the size of the string. So O of 2n, so O of n. So O of 1 versus O of 2n, basically I'm saying solution 2 seems to be more memory efficient. Therefore, I think that's a solution I'm going to try to implement. If it seems like I pulled this character array thing out of my butt, it's because I did. But I learned it doing the group anagram problem, which I did about a week ago. Yeah. And it is interesting to me to think of the trade-offs on how you could use it to implement this problem. But yeah, let's do this. So I would need to make one pass, right, for each character in the input array, in the strings, in S. Okay, so I wonder if we can be fancy schmancy and then do it like this, where we iterate through both lists at the same time. Okay, let's actually just do it for one first. And then if we can look up the notation on how we could do it in one loop if we really wanted to. So for each char in the string, first thing I'm going to do outside of this is make a character array. And I'm going to make 2. We're going to call this schar array. And then we're going to call this tchar array. Boom. And then for each character in S, basically, first we take the ASCII representation of it, which I think we get using first we can calculate our offset, which is going to be, I think, the order function. And then let me make sure I know what I'm saying. Python order function. No, not sorted. Okay, it's not called order then. Python ASCII value Python function. It's called ord. Okay, close enough. It's close enough. Ord. There you go. So then we also calculate cur char ASCII value. Let's call it the value as ord. Okay, and actually this is not the value. This is more of the index. Cur char index. It's going to be the index value into my char array. And this is going to be order of the current char. Then what I'm going to do is, and this is going to be the order of the current char minus the offset. So one would imagine if, by the way, lowercase ASCII in value for lowercase a in decimal, I believe is 97, I think, or 67. Might be 67. But anyways, whatever number it is, if my first character was A, and then I subtracted the ASCII representation of A from A, what would that give me? Index 0. So I would know to increment into my character array at index 0, which represents the letter A. So the way I would do that then is I'd go into my, and I have to make this 26 zeros. How do I do that? Okay, how to prefill array in Python with zeros. I can just do 0 times 26. Perfect. Cool. Yeah. 0 times 26. 0 times 26. And then we index into the schar array using the index we just calculated of the current character we're at in the string. And then we increment it by 1. And we have built our character array for the S input string. Now, to do it for the T input string, you would just change this to T and this to T, and then you're done. Now, all you need to do is check if schar array equals tchar array. So what this means on a more conceptual level is if two strings have the same character array, that means they both have the same exact number of, they both have the same letters and they have the same amount of each letter, which is the definition of an anagram. Yeah. So then if they're equal, then we would return true because they're anagrams. And otherwise we return false. Now let me think about if you passed in two empty strings, that should be fine because then both char arrays would be 0, would just be 26 zeros, and then they would be equal, so you return true. If they were different sizes, okay, so I could make a check here, like if they're different sizes, immediately don't do any of the code. And I think that'd be the most efficient thing to do, because even if they were different sizes, yes, the character arrays would be different. But why even have to go through all that process if I know they're not the same size in the first place? So we can do if length of s is not equal to length of t, then immediately we return false. And like I said earlier, I don't know if iterating through both, now that we know they're the same size, I don't know if iterating through the like both strings at the same time is faster than separating it out into 2 for loops. I guess what would that save? That would save one offset calculation, which honestly, why is this being calculated for every iteration? That doesn't need to be the case. So we can actually extrapolate that variable out of here because the offset is going to be the same every time. This is going to be different for each character in both strings. So that two separate index calculations do need to take place. And two separate indexes into the character array need to take place. So I think having a notation where I iterate through both strings at the same time wouldn't actually save me anything. This is the only thing I can save, this one little calculation, which honestly could be a lot because I don't need to do this for every A. And you would think it doesn't matter, but my last CS class I took before I graduated, we had to do a Huffman coding project, and I had a problem similar to this actually, where there was actually obviously your code had to pass the test cases, but it also had a speed requirement for efficiency. And I had an issue like this where I was basically calculating some sort of length inside a for loop, right? X amount of times, however many times it was doing it in the test cases. When that length, and then using it for a calculation when that could have just been calculated once. So these things are probably actually kind of good to think about, in my opinion. So like I calculated something one time instead of thousands of times, and that was what actually made my code fast enough to pass the conditions. Anyways, good thing to think about, in my opinion. I'm gonna run this now. Control apostrophe. Cool. Let's see. I mean, I'm trying to think of any more test cases, but I don't see why this wouldn't work for every other solution. So we're gonna submit it. Nice. Okay. And again, to recap, I can get rid of this because this is the solution we went with. I want to say the space complexity for this does reduce down to O of 1. So and remember, not you remember, but me, more for me to remember, the big O notation, it's not about speed or space, even though that is how it's treated usually, right? Like it's not a measure of speed, it's a measure of growth, growth in terms of input size, which are actually two different things. Because if I'm only measuring growth in terms of input size, right? For example, I could have something that takes super long to do, right? But it's O of n, which is traditionally considered fast because it grows linearly with my input size. That's a horrible example. basically, there's a difference. I need to look into it more. You probably need to look into it more. I Maybe you don't. Maybe you're a genius. I'm not. So, anyways, this should be O of 1 in my humble opinion. I'm gonna submit that too, just for a bigger dopaminergic response. And now we're gonna watch the solution together to see if. Oh, actually, first I want to see what my old solution was. For some reason, the memory did kick in for this problem, even though it completely did not kick in at all for the previous problem I did. But I'm pretty sure I used dictionaries because I hadn't learned the char array solution yet. Yeah, well, let's see. Oh, right. I have to. Oh, brother, what? Oh, no, I did use dictionaries. Yeah. Yeah, so dictionary by the char, increase it by one else. Okay, so this else was like the case where I insert a character into the dictionary for the first time. So it needs to have a default value of 1 or 1, and then I can do this kind of plus equals 1 notation, because before I remember it wasn't working because I was trying to trying to increase something by 1 that didn't exist because I hadn't actually put a key value pair in. But I believe in the video he does mention that there's a way to like just declare this to be some sort of default thing. Yeah, I think my code I wrote today is like way better than this. I think. Who knows? I think it is. Oh no. Let's watch the solution now. $12. God damn. Sorry, I almost cramped. But yeah, I definitely need to be constantly fidgeting and moving in my chair because I get very uncomfortable otherwise. I think everything following along completely so far. Talked about all of this, which is good. So this seems to be the solution I implemented in first my first crack at this problem 3 weeks ago. Oh, is explaining solution one, and then there's about to be solution two. Hmm. See, I know in Python you can just check dictionaries for equality, but I guess that equality check actually is another. You know, technically it's iterating through every key, like he said. And what he said previously is that since we do that size check in the beginning, um, wait, let me think about this. I guess he's saying he only has to iterate through the keys, um, through the keys of one of the strings, and then make sure that it has the same keys as a dictionary for the other string. I don't necessarily agree with, because what if a three and one were switched? Let me go back to understand what he was saying completely. So he's saying after you build the dictionaries, we're going to iterate through the keys of one of the dictionaries. Oh, you do have to check that the count is the same. For You have to look at string S's A and make sure that T's A has the same count. Okay. Okay. Yeah. 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 Okay. So you iterate through one of the strings hash maps and make sure uh, key by key and value by value it's the same as the other hash map. But then you don't have to do it the other way around because we know they're the same size. So there'd be no situation where, for example, this T would have an extra letter on top of all the letters and number of letter occurrences that string S has. Where this, for example, like this part would return true because it's the exact same as T, but T is not the same as S because there's this extra letter. But that can't happen because of the size check we do in the beginning. Okay, yeah. Maybe I should have mentioned that when I was discussing the time complexity earlier. Okay, I'm just gonna. Why not watch the whole thing? I guess. Okay, sure. Good to know we can make two dictionaries in one line with commas. Probably infinite amount of dictionaries or lists or any other structure. I'm assuming. Is this reaction content? I'm not listening to music. I'm playing a song in my head. If you're curious, which you're not, but if in theory you were, the song, not this one. Uh, no, no. Oh, good song. This one. All right. Oh, it's not even showing up on the screen. Okay, that's fine. All right by Ashes to Amber. Good song. Mhm. I remember having the issue the first time I constructed the solution using two dictionaries. So it saves you a if condition, if else condition. Oh, one for loop. Hmm. Oh, yeah, he's about to dunk on my two for loop solution when I believe he's going to use the character array in the next solution. But this looks way better than my first solution too. Okay, so this is actually better than just directly using like the Python dictionary equality check, uh, because it returns false as soon as a difference is found, right? It again, kind of like what I did for my first problem, the first LeetCode problem I did today. It's better to return false. It's better to return as soon as you can, and by waiting to see when it's false, and then if it's not false, then it's true. Then basically, it in a lot of situations, it's going to reduce the amount of operands I'm doing. So I think I can do something like that right now, right? So like I said, um, the issue with this, hold up. That's fine. The issue with this is, okay, an anagram, it can only be an anagram. The only way you know for sure is if you check the entirety of both strings, right? So that means in this case, returning true is like the worst case, not worst case, but it's the possible output of this function that would take the most amount of time, right? So it would make sense, more sense actually, for the output that would take the most amount of time to be our else to say. It would be like our worst case scenario in terms of time. Um, our best case scenario is that we very quickly find out that the two strings are not anagrams, right? And that would be returning false. So if you could, if the way you can, I need to actually write this code first, but the way you can think about this is kind of like there are infinitely more situations for two different strings of the same length, which you can input, in which returning false as soon as you know they're not anagrams is going to be faster than what I had earlier by checking both arrays completely and then returning false if they're not the same. Because the only times when that code structure would be take the same amount of time as the code structure I'm about to implement would be when the strings are anagrams, but the amount of strings of the same length that aren't anagrams are actually like they scale like an insane amount, right? 26 times 26 times 26 for every single character. All that to say is that I'm going to want to write something like this. And it seems like I'm adding a for loop, but I'm really not. Well, I am. It's in the previous code. I also had a for loop. It just was invisible by the Python, like data structure equality check. But we're going to do for every char in and again, we're only going to look through one of them. So let's say S char array. I'm going to want to check. I'm going to return false if what? Shit. I hate it when I mess up the tabbing. Okay. If going into my schar array, right, getting the I can't necessarily do I have to calculate the offset again? It seems like I do to get the correct index. Yeah. You know, I wonder if there's a way to like, no, there's not. Okay. You have to calculate this again. Order of the char, which is the ASCII decimal representation of the current char, minus the offset of the order of A, which is something we predetermined. And we can use this. And we say if it's not equal to T char array cur char index, return false. Otherwise, we'd return true. Yeah. So let's see if this works. Oh, crap. Hold up. Oh, I don't have to do this order thing anymore. I'm kind of dumb. Because it's not, I don't have chars in my char array. I have nums. I have numbers in my char array. And the way I do this is basically might need a like an index and an enumerate as well. Let's see what happens if I add that. Again, this basically just allows me to have zero-based indices in the loop along with the actual values that those indices correspond to in the array. But I think what I'd be checking would be so I want the number at so I really don't even need num. I don't need num actually because, yeah. This is like letting me index into it myself. Yeah. This is interesting. I don't think I've ever constructed a loop where I just use the index, but that makes more sense, like in terms of when you make loops in like C and C++ and stuff. Sorry. Received a call. It's okay. I'm about to wrap this up. Yeah. So basically what this is doing is it's checking each character, the number of occurrences of each character in each string. And if at any point if the number of occurrences don't line up, I'm going to immediately return false. Otherwise, I'm going to return true if they're all the same. So this has that exit out if it's bad, or it exits out for the it exits out as soon as possible, and it only takes the worst case amount of time if I couldn't exit out at any point before that. So I think this should work now. Damn. Why is that? List indices must be integers or slices, not tuples. Why is IDX a tuple, bro? how to make original for loop in Python. I'm making a mess on my desk here. Sorry. This is really annoying. Yeah, okay. Can it be explained why exactly I can't use... Why is IDX a tuple? Why can't I think of the Python way to write this? It's making me very angry. I'm gonna have to throw this in ChatGPT, unfortunately. Wait, just this error. I just want to see what ChatGPT has to say. Please don't give me a solution to the goddamn code. Oh, interesting. If you use only... wow. If you use only one variable before you use enumerate, before the in the for in statement in Python, it just, that one variable becomes a tuple. And you have to access the index part of the tuple you want. If you use two variables, then each corresponding part gets saved to then the first part becomes the index and the second part becomes the value. Yeah, okay. That's interesting. I did not know that. So that kind of sucks that you do need to have this in here. Either that or I'd have to like do something that looks like this, which looks very, very dumb. And do you want to do that? That's probably very confusing. So it'd be better just to throw the num in there to make the code more readable, I guess. Cool. Okay. I think this should be more akin to what he's about to drop in his solution. Okay, let's continue watching this. Pause. It is very interesting how more lines of code does not correspond to less performance. I think I need to get rid of that. Yeah, that's like actually complete. There is no correspondence there at all, especially not in Python. So yeah, lines of code does not equal better performance. Less lines of code does not equal better performance. You remember that. Can't believe I didn't think about that. Always need to think about sorting. Damn it. Damn it. Yeah, that is way less complex and more space efficient than my solution. If what he said is true, though, is my solution still faster, though? Because mine is O of S plus T. Hold up. Mine is worst case O of S plus T plus another S or T. So it's like 3n, which I guess gets dropped, but this is n log n. I'm not sure, actually. I guess there's going to be a moment where my solution is faster, but I guess there's gonna be a period of time where his solution is faster, and then at a certain uh, input string length, my solution should overtake that, I think. Sorry, I really have to use the restroom, so I'm gonna skip to him writing all the code. Oh, okay. Super interesting. Um, I still think my solution in most cases is both better for space, is the best solution for both space complexity and time complexity, and I'm very willing to be wrong on that. I think it's better than the dictionary because it has a better space complexity, and I think it's better than the sorting method because it has a better time complexity, um, and technically has the same space complexity as the sorting algorithm, but not really. They both don't scale with input size, but mine scales with number of inputs, which is interesting. And uh, the sorting algorithm would not scale memory wise with number of inputs, even though technically, I guess sorting algorithms do use memory. Who knows? Nitty gritty details right there. But that wraps up this video. Uh, yeah, so that's is Anagram, and wow. Well, that email will be deleted soon, anyways. Uh, Is anagram. That's valid anagrams and contains duplicates. Yeah, glad I was able to do those relatively well. Definitely still learned a lot on my second go through. So glad I went through them again. Yeah, have a good day. Might stream later to do my project, might not. Who knows? Bye.